Okay, 11.3, geometric sequences. Students will be able to use the geometric sequences and find geometric means. Okay, a geometric sequence, this is just a sequence where we multiply each term by the same number. In which, let's see, it officially says in which each term after the first is found by multiplying the previous term by a constant r called the common ratio. That's what the r is, the common ratio. Because it's a ratio. We just take the current term divided by the previous term, and that'll give us r, because we just work backwards and get r. So are these geometric sequences? If so, what's the r? Well, let's take a look. 5 times 3 is 15, times 3 is 45, times 3 is 135. So the answer is yes, and the r value is 3. How about these? 20 to 10 to 5 to 2.5. It may not seem like it, but the answer is yes, and the r value is 1/2. We're multiplying by a fraction. It's the same thing as dividing by 2. It is multiplying by 1/2. Okay, and then here, 1, 2, 6, 7, 11, 12. What's happening here? Well, the pattern is not just multiplying the same number every single time, so this answer is no. All right. So that's what a geometric sequence is, just multiplying a number by the same thing every single time. We have two different formulas. We have the recursive, where this gives us the next term, or the previous term, and then we have explicit, which gives us an exact term. So we're going to practice writing both of these real quick. Let's see, before we can write this, we have to know what our r value is, and we have to know what our first value is, usually. Our r value here, what are we multiplying by? It looks like we're multiplying by 3 every time. And here, it looks like our r value is -6. So let's write the recursive for this one first. Recursive is just going to be a sub n equals a sub n minus 1, meaning the previous term, times by 3. That's it. The explicit then is going to be a sub n equals a sub 1, which is that means the first term, which is 11, times the r value, which in this situation is 3, to the power of n minus 1. Okay, I'm going to have you guys do part 2b there on your own. You may want to pause the video because I'm going to put the answer up in just a second. Okay, so the recursive is a sub n equals a sub n minus 1 times our r value, which is -6. The explicit is a sub n equals 1, because that's our first term, times -6 to the power of n minus 1. Okay, now it says find the 12th term. Well, if I was to use the recursive formula, I'd have to put in the first term, get the second, put in the second, get the third, put in the third, get the fourth, and so on and so on and so on. But if I use explicit, I can get right to the 12th term. Let me show you how. Let's write the explicit for this. It's going to be a sub n equals 3, that's my first term, times my r value, which is what? Sorry, I put a little 1 there. But what is my r value? It looks like it's going 3 times 2 is 6, times 2 is 12, times 2 is 24, so my r value is actually 2. And then to the power of n minus 1. Well, now what is the n that I want? I want the 12th term, so I'd write this as a sub 12 equals 3 times 2 to the 12 minus 1, so that's the 11th. All right, well, now I just have to figure out what is 2 to the 11th power. My calculator says that's 2048. It's like 3 times 2048. And that is 6144. So we can say that the 12th term is 6,144. So first thing I did is I wrote the explicit equation, and then I just plugged in my values. So I want you guys to try the second one on your own. You may want to pause the video again because I'm going to put the answer up in just a second. Okay, it looks like my r value is going, I'm dividing by 10 or multiplying by 1/10. And so when I fill out my equation, it's -1,000 times 1/10 to the power of n minus 1. Well, my n in this situation is 12, so it's negative 1,000 times 1/10 to the power of 11. When I figure that out in scientific notation, I get negative 1 times 10 to the negative 8th, or in just pure decimal form, it would be negative 0.7 zeros and then a 1. All right. What if I wanted the geometric mean? Well, this is actually pretty simple. For the geometric mean, I literally just multiply these two numbers together, put them underneath the square root, and that's my geometric mean. So 20 times 80, well 20 times 80 is 1600, and the square root of 1600 is 40. So my answer for the geometric mean here is just 40. So we're going to do the same thing here. A couple of things to clarify though. This is all one number. That's 19,683. So you're going to find the geometric mean of these two numbers. That's going to go here, and then you'll find the geometric mean of the missing number in 19,000, and the geometric mean of the missing number in 243. So I'm going to let you guys go ahead and try that one. Just follow the same pattern I just did here. Multiply together, put them underneath the square root. Plug all those numbers in, and then I will put the answer up in just a second. So you may want to pause the video now. Okay, I got 2187 for the middle number, and then when I did it again with these two numbers, I got 6,561, and when I did it again with these two numbers, I got 729. All right, let's go on to the next page.